Good afternoon, everyone. I'm super excited to be here at SciViz 2019. When I was invited and I looked at the list of other presenters, I was a little bit confused because my work is a little different than everyone else's. I'm a photographer, and I'm the lead photographer at NASA's, for NASA's James Webb Space Telescope. I work out of Goddard Space Flight Center. It's hard for me to say that because I've been traveling back and forth to California following the telescope for the last couple years. But Goddard Space Flight Center is in Greenbelt, Maryland, and it's the largest collection of scientists, engineers, technicians in the U.S. dedicated to conceiving, designing, building, and launching spacecraft for Earth observing and astrophysics studies. So, title of my talk, Epic Space. So a little bit about my photographic background. I got my first camera at 9, but before I got my camera, I liked to experiment. I liked to, blow up things, and photography had a chemistry element that I really enjoyed. And I asked my parents to get me photographic chemistry, and I would just make latent images, photograms actually, exposing paper to, or exposing photographic paper to light with different objects, using different types of light, and then creating photograms. And that was a less destructive creative process for me, which was also very, very scientific. Got my first camera at 9, and continued shooting, and eventually got a job at a camera store and that sort of thing. And see, the title's already up there, so let me bring that image up. So in 1985, I went to, so Ansel, I think he passed in 1984. And in 1985, there was a retrospective of his work at National Gallery of Art in Washington, D.C., and I took a bus and a couple trains. And I had never actually been moved by photography until I saw his stuff in person. And it wasn't necessarily the subject matter, because I'm a city kid. So seeing the mountains and the sand dunes didn't move me, but it was the presentation, and it was the accuracy. It was the fact that, when you looked at his images, you could actually feel something, right? And this image, of course, one of his very famous images, and if you ever listen to an account about it, it was, he almost didn't make it. It almost didn't happen. So it'd be good to research that. Let's see. What's next here? Okay, so later in my photographic studies, especially large format photography, I learned more about Ansel and his process. Obviously, he was a huge influence on me, and his process was also very, very scientific, and that really turned me on. The zone system, if any of you are familiar with it, was a process that Ansel developed in order to basically control the exposure through the chemical process, okay? So through basically the variables of temperature and time and dilution, he could change the tones in a given image, starting with the film and then with the print. And I studied that, and we're talking about 1991, pre-digital, and that's what I thought my world was going to be like the rest of my life. So here's Ansel, his camera. Should be building in. Is it building in? All right. We're wearing different things, but so when I first saw Ansel with a large format camera, I was thinking, like, who would want to shoot with an old-fashioned camera like that? Didn't mean for that to build in, but I eventually obviously got my own. So after school and before joining NASA, I worked editorially, shooting for local and national print publications. And my subjects were usually related to politics, social justice, culture, art. I brought my own sort of touch to my work, as most creative photographers do. And I wound up shooting with my large format camera a lot. So let's see. And We're looking at 1996, 1997, I think these images were made. In 2000, I learned about a job at NASA Goddard Space Flight Center. And I had a decision to make. Was I going to continue to sort of be a freelance photographer, or was I going to try to become a corporate photographer and shoot the kinds of things that they need in a corporate setting? Headshots, group photos, that sort of thing. So one of the issues I had when thinking if I was even going to go for the interview was figuring out what a photographer at NASA might do. Because when I thought about NASA, this is basically what I thought about, right? Of course, this is Moonrise. I think it's an Apollo 8, Earthrise, Apollo 8 image. It's made by Bill Anders, right? And I learned something interesting about this photograph, and that is that the Apollo 8 astronauts took a Hasselblad camera with them. I think they had 3 film backs, and they were not planning on shooting any images of the Earth from the vantage point of the moon. They took the cameras for technical purposes. In fact, the leader, or the head of the mission, basically didn't like photography at all. He thought it was a waste of time and would get in the way. Bill Anders, well, they all were mesmerized when they looked out the window and saw the Earth, and Bill Anders made this photograph. Let's see. Likewise, everybody recognizes that one. And I think by the time Buzz Aldrin made this photograph, photography had a different they had a different point of view of photography at NASA. So Buzz Aldrin intentionally made this photograph. Okay, it's building it. All right, there we go. And Apollo 17, Blue Marble. Again, by Apollo 17, NASA firmly believed in the power of imagery to push their message. So those are all astronaut images. Again, I'm thinking, well, I won't become an astronaut. And what does NASA have in store for me in terms of imagery? Also looked at images like this. This is the Hubble Deep Field. And again, I'm thinking, well, what does that have to do with me? Beautiful, though. So apparently this was a patch of sky that was completely dark, and there are over 10 million galaxies in that small area. Okay. So I did take the job. It's kind of hard to pass up. I showed my work. I was hired the same day. My first assignments were sort of the standard corporate photography things, headshots, award ceremonies, events, things that weren't very exciting. And I just kind of had to stick with it and continue to show people what I could do. We had a digital camera then that was kind of archaic. It was the Kodak 460. It took 15 images before the batteries died. But the thing is they hadn't had anyone in the position that would take the risk to shoot with the camera. So the other photographers would shoot with film, and they'd send the film out, and it would take 2 weeks to get back. So our photo department was used less and less. I took the camera, and because I had shot large format and medium format, 15 shots didn't really bother me because I was used to shooting sheet film, so I could get a good image in one take, right? So these are the first kinds of images that I made that I was really proud of in that setting, sort of using my full skill set. First image is a designer of a board that was going to be used in an astrophysics application. That second image is a vacuum chamber, which they're pretty common at Goddard. And those are blankets. Everything has to be tested in vacuum chambers before it goes to space. So those were blankets that were going to be used on a spacecraft. And this third image is of a scientist who was working on algorithms for Mars rovers. So we don't send Mars rovers. NASA Goddard didn't work on Mars rovers, but they were working on the software. And they converted an atrium inside of one of the buildings into a landscape, a Mars landscape. Here we have the mini power tool, which was used during the Hubble servicing missions, and that's the designer. It's another one of my portraits. Oops, too fast. Okay. All right. Okay. Second one was a portrait as well. After 6 years, from 2000 to 2006, I took a different job at NASA Goddard. What I did was I took a job in a mission, and it wasn't what I thought it was. It was the Hubble Space Telescope mission, and I joined a staff of photographers that documented every aspect of the mission. So nuts, bolts, wires. We also did crew familiarizations. I also traveled down to Texas. I didn't shoot when we went to the neutral buoyancy lab. I just loaded the camera. It was a very technical job, not very creative. And this was one image that I made that I'm super proud of, and it's of Drew Fustel, who was one of the STS-125 astronauts at the neutral buoyancy lab, made with my camera. And just a story about this image. So I pulled the camera out, and Drew gives us the astronaut smile. That's what they're trained to do. And I said, no, don't smile. He couldn't hear me because he had the visor. And so we made this photograph, and every time I see Drew, he tells me how much he loves it. So I worked on the Hubble Space Telescope project for approximately 3 years, from 2006 to 2009. Like I said, it was a lot of nuts and bolts, a lot of very technical photographs, and I did get a chance to see a launch at STS-125. It was amazing. And before the launch, I got a chance to actually work inside of the shuttle bay, documenting cable connectors. Okay. All right, so mission's over. What are you gonna do? So basically, when you're on a mission, you have to find another mission to work for. And the James Webb Space Telescope came knocking on my door. I had an inkling as to what the James Webb Space Telescope was. I had heard of the Next Generation Space Telescope, and NGST had been renamed the James Webb Space Telescope in 2002, which was an event that I actually photographed down at NASA headquarters. When they renamed it, they gave the family a plaque. James Webb, of course, was NASA's first administrator. He's the administrator that is credited with pushing science as part of the mission. So this became my studio. This was the SysDiff, or this is the SysDiff. Now, the SysDiff is not empty right now, but this is what an empty SysDiff looks like. That wall that you see there is HEPA filters, and it's about 10 stories high. So the entire wall is HEPA filters, and it's a class 10,000 clean room, which means it has the same cleanliness of a surgical room. That's what they tell us. So working there, you have to don the suit, and it's to protect the space hardware from you, basically, your skin cells. This was the first piece of hardware, first piece of Webb hardware that I photographed. So it's not the thing in the front, it's the thing in the back. The sort of skeletal structure is the ISM structure, which is the backbone for the 4 instruments on James Webb. James Webb has 4 basically cameras. So the fine guidance sensor, the NIRCam, which is a near-infrared camera, NIRSpec, which is a near-infrared spectrometer, and MIRCam, or MIRI, which is a mid-infrared camera. James Webb is an infrared telescope. It's going to look back 13 billion years to the early universe, And it does it by looking at that faintest light, which has shifted into the red. You learn all this when you work on a project like this. This was the first image to be printed in a national publication. Popular Science picked it up. And ironically, there is no hardware in this image that will fly into space. So this is test hardware. So the telescope had to be optically tested in order to make sure that everything was aligned. So this hardware is all optical hardware, and it's going into the Space Environment Simulator at NASA Goddard to be cryogenically tested at the temperatures that Webb will see. So this, people ask me all the time, well, how come Webb hasn't launched yet? Well, they test everything. And they test everything, and then they retest it in order to make sure that it's going to work when it makes it out 1 million miles from Earth. Yeah? That's what the bottom of that SES chamber looked like as they're putting thermal blankets in. This is just before the doors are closed. Eventually, the instruments made it to the top of that chamber, and this is a photograph that I made with Desiree Stover, who was also a photographer on the project. That's Desiree in the shot. This image actually ran in Washington Post. Again, it's not James Webb, but it illustrated progress, and that's what everyone was looking for with this particular project. So the instruments are encased in that structure you see there, and everything is temperature controlled, right? It's going down to, the telescope itself is going to operate at 40 Kelvin. So you guys who know what 40 Kelvin is, it's not too far above absolute zero. And that's how they're going to be able to keep the telescope cold enough to see what it needs to see in terms of the redshifted light. So do you remember the empty structure I showed you earlier? That is the structure complete with the instrument package. So one of the things I can say about the photographs that I make is that they're not straight images. They're lit. They are adjusted for contrast and light. And I do that in order to evoke feeling and emotion from people who look at them. I want you guys to say, wow. I didn't hear anyone say wow, but. Wow. Okay, all right, okay. And you know, so one of the things I learned about Ansel Adams, to go back to him for a sec, is that none of his images, his beautiful images, are straight images. So they're not what the negative showed him. He considered the negative to be the musical score and the print to be the performance. That's a quote. So this is an image of it's in a vacuum chamber. So a lot of vacuum chambers, obviously. This is an image of the MIRI shield. So the MIRI is the mid-infrared telescope. It's one of the mid-infrared camera, and it is one of the instruments that has to be kept the coldest, and it has to be shielded from the rest of the telescope. So this engineer is actually working on the MIRI shield inside of one of our small chambers. It's another image that gets a lot of press, and they call it a Webb image, when you guys can see the whole telescope is not there. But that is a mirror, and they're testing out a cleaning process that will never be used on the telescope. But I had to make this photograph. So that's basically carbon dioxide snow, and they're spraying it on the telescope to polish it or to clean it of contamination, right? So here we go. This was the first flight mirror to arrive, and it was exciting. I mean, there were people lined up at the viewing window that we have at Goddard, 2 viewing windows, so one on the floor and one in the air, and it was really, really fascinating. These mirrors are beryllium, and they're coated with a layer of gold. There are 18 mirrors altogether, and the layer of gold on it is so thin that it's only about the mass of a golf ball, right? If you can believe that. Beryllium was chosen because it's thermically stable, right? It doesn't expand or contract. This was the second mirror. It got less exciting as the 18 mirrors came in. But, I mean, what you have here is you have contamination control engineers, you have quality engineers, you obviously have a photographer making a photograph, and they're looking for contamination or imperfections, and generally there aren't any problems. So, this is an example of how those mirrors got placed onto the structure. It's a robotic arm guided by, remote control, but individuals were actually under the structure. This isn't the flight structure, but a test structure. Again, everything that they did, they practiced over and over again. If you look around the mirror, you see things standing up. That's for metrology that they use to measure the movements. Every mirror made its way through the halls of Goddard in these containers for measurement. So that's another one of my favorite images that I just had to show you guys. All right. It's another one of that arm. And if you look on the right, that is the Pathfinder. Pathfinder, again, is not the telescope. They placed 2 mirrors on the Pathfinder in order to send it down for testing at Johnson Space Center in Chamber A. I'm going to show you a picture of Chamber A in a second. But the Pathfinder basically is the same size and scale of the structure, but it doesn't have the 2 wings, and they only put 2 mirrors on it. And if you ever make it to Goddard Space Flight Center, it's still in the SISTIF, that big room that I showed you at first. So they did cryogenic testing of the actual instruments at Goddard in the space environment simulator, but the telescope itself would not fit there. So we had to go to historic Chamber A. And Chamber A is the chamber that they did manned astronaut testing. They would actually put men in the capsule and suck all the air out and cool it down, and they would stay in there for 2 weeks at a time. And if you look, if you want to get an idea of the scale, I think I can zoom in here. There we go. So there's like 20 guys and they're working on that. So the coating on the back is actually pure black, and I had to pump a lot of light in there to get it right, and I had to make a couple of trips to the 6th floor to adjust the light. Just to give you guys an idea of how hard it is to make a photograph like this. Chamber A did have to be retrofit in order to test Webb, because Chamber A was usually cooled down with helium, nitrogen, liquid nitrogen. And in order to get to the temperatures cold enough for Webb, it had to be cooled with helium. So there's a helium shroud inside of Chamber A. This is Nathan Abraham. She's in the basement, or the plenum, of Chamber A. She's actually the inventor of that white panel, which collects molecular contamination. So I took the trip down there with her, and this photograph has actually made quite a bit of rounds as well. Flight structure. So it's huge. See the 2 guys in the middle, or on the end there? Gives you an idea of the scale. You already know how the mirrors came on. You already know they're 18, so I can show you that image now. So that's the first, I heard the wow. This is the first time that we had a chance to actually photograph the entire set of mirrors without a lot of activity going on. And so I got a chance to have time with it, as well as our video team, our media team, and it was really an amazing experience to see it lit up like that. So it was actually low light, and then we adjusted lights, and we had a lot of fun. The image on the left is another low light image of Webb, and that's a timed exposure. It's about 1.5 minutes, and you see the trails of people and their contamination control engineers doing an inspection, and it was almost completely dark. So in order to illuminate the mirrors in this photograph, I had to actually illuminate the areas of the room with light that the mirror was reflecting. There we go. I love this thing. All right. So this is the telescope being prepared for some vibration testing, which happened outside of the clean room. So they have to build a clean room around it. Back at Johnson Space Center. And there's a telescope outside of Chamber A. So we spent about a year down at Chamber A for testing and for integration. And these are the moments just before and when it was actually pushed in. That's the telescope in Chamber A. And that's post-test. Gives you an idea of scale. Okay. So, I haven't showed you any transportation images, but they've actually shipped this telescope around the country, from Maryland to Johnson Space Center in Texas, and now it's located at Northrop Grumman in Redondo Beach, California. This is an extremely rare photograph of the telescope, and I made it on a Hasselblad 100 megapixel camera. It shows the secondary mirror deployed above the center section of the primary mirror. Obviously, the mirror has to be folded back in order to fit onto a rocket. And there's also, I could also call this image a selfie, because if you zoom into the mirror there, you see me. But it'll never be, there was no other time that it was in this configuration. So it's a very, very, very rare image. Looks a little different. So this is the almost the flight configuration of the telescope. The shield underneath the telescope was recently integrated onto the optical portion, and that shield is what keeps the telescope cold enough in order to operate. So it shields the sun's radiation and heat from the instruments. Okay. So it looks like it's finished, but it has about a year's worth of testing to go. It will launch in March 2021. A few more images of that. One more image of that. So I'm going to leave it here for a second and just sort of, go into why this is so important to me, making these types of images and working in this setting. Like I said before, I live just outside of Goddard, and science was really interesting to me. And I don't know, I never ever got a trip there. My school never took me there. I was never exposed to some of the things that I think would have pushed me into the realm of being a scientist or an engineer. Now, yeah, I could have done a little more research and figured out what a scientist and engineer did, but I never saw it. So it's important for me to make these images so that people see it. Yeah. I'm going into some of my personal work now. So a writer and I, a former NASA writer and I, are actually working on a project where we're going into research settings where people are looking into how we're going to live in space in the next centuries. It's probably going to start off as work. And this is Mr. Purrington, and what he's doing is preparing a sample of lunar regolith sample. It's not real lunar regolith, right? So it's artificial lunar regolith. And he's baking it in this vacuum chamber in order to extract water. So if we are going to live on the moon, or if we're going to work on the moon, we're going to have water. And the water supposedly is there. But the methods are still being developed as to how we're going to get it out. So we're finding these places where we can go and photograph these researchers and these scientists, photograph their work. There's a close-up of what's happening inside of that chamber. So that light is just a 12-watt bulb. Because of the temperature differential of what lunar regolith would be and the pressure, you don't need a lot of power in order to pull the water out, apparently. Right? It's Phil Sadler. Phil Sadler was one of the first people to grow plants in Antarctica via a greenhouse. So Phil Sadler is working with the folks at University of Arizona to come up with ways that we can grow vegetation either in lunar surfaces or in Mars. And this is an image of Phil Sadler inside of Biosphere's 2 lung with one of his lunar greenhouse prototypes. He was quite a character. I'm actually finishing a little bit early, so I can take some questions. This is my last slide. Yes, sir.
2 questions. Let me start by saying, wow. I've dealt with a lot of NASA imagery during my time, and this is some of the finest I've ever seen. It's really just phenomenal.
Thank you. I appreciate that. So can I just sort of dovetail on what you just said? When I first started, a gentleman, a fellow photographer, I can't mention his name, he said, you know, why are you taking all this extra time? You know, it's good enough for government. Or they're not interested in pretty pictures, right? So I'm going to let you finish, but I have some more to say.
It's ironic, I think, and correct me if I'm wrong, that this imagery, which is so beautiful, is going to be published in manuscript.
Yes.
Well, it'll be some of the finest to ever come out of NASA. My
Thank
second question is, you speak extremely well about the science involved. Before you got the job here, were you well versed in the science of astronomy and space travel?
Only as an amateur, a lover of science, a lover of astronomy. So
Quite a bit while you were.
I have, and you know, and it feels like very similar information that I deal with, you know, on a day-to-day basis when I deal with photography. It's very technical. It's, you know, I make fun of some of the scientists, and I say, well, all you guys really do is throw cameras in space, right? But it's, you know, it's all about image making. So.
Thank you very much.
Thank you, sir. So, yeah, there's another question?
I was just wondering, I mean, obviously you're setting up lights and things.
Yes.
How much freedom do you have to say, like, hey, will you stand over here? Or, like, do you just not interfere at all?
That's a good question. I'm glad you asked that. So I don't have a lot of freedom to do that. A lot of these are actually captured in the moment. I set up lights ahead of time, sometimes 2 and 3 lights. I haven't run up and down the stairs in the SysDiff in a long time, so I've gained a little bit of weight. But when you set up these lights, you know, the remotes don't always work in those environments, so you might have to go up and make an adjustment. But it becomes second nature. There was one image of 2 guys looking at the fully deployed telescope. I went in to photograph the telescope. They walked over to look at something, and I did shout to them not to move. So, and they stayed there. And that image actually ran in the science section of New York Times. I was really, really happy. Yeah. Mm-hmm. So I think that the popularity of these images has been pushed forward by social media, obviously. NASA has 50 million followers. NASA Goddard has 2.5 million followers. NASA Webb has 300,000 followers. And the more and more they push these images out, I get a chance to see really that the public has a thirst to see what's behind the scenes in making these observatories. So the next big observatory is W1st, and it's being assembled at Goddard as well. And hopefully I'll have a chance to make some photographs of that as well. So, yes.
So when you're talking about these aren't just technical to you, or that you are moving around lighting and you're trying to get an effect, but it's not sentimental, what is it that you want from your photographs?
The wow.
Your creative.
So I want you to feel what I feel, basically. You know, so I feel there's a sense of awe when I look at these things. I feel awe when I talk to the scientists and engineers about their work. I feel their passion. I want you to feel that passion. So that's my goal, you know, if I had to have a singular goal. Yeah, so hopefully I get that comes across. Yeah. Is my time almost up?
Well, we're back on schedule now, so.